I know. What can I say? On 5. You're buying cars. It has the model of 18t squared, so on and so forth. Where C is the number of new cars purchased, a T equals 0 is the number of cars purchased in 1979. What year will the number of new cars purchased reach 19,000? Excuse me. So what you're doing here is this is the new value of C. So you're going to solve for T. You have 19,000 equals 18t squared plus 136t plus 6444. Now when you do that, the easiest way to solve this problem, not to graph it, not to do anything else, but to just set one side equal to 0 and use the quadratic formula. When you set one side equal to 0, you get 0 is 18t squared plus 136t minus 12,556. What I'm going to do from here is just use quadratic, because the quadratic formula is going to give me my two values of 0, my two intercepts on the x-axis. So you have opposite of b, negative 136, plus or minus the square root 136 squared minus 4 times 18 times negative 12,556. All over 2 times 18, which is 36. Okay? Now, when I do all of that work, my discriminant, 136 squared minus 4 times 18 times negative 12,556, gives me this god-awful large number. Do you agree? That's the discriminant. That discriminant is positive, isn't it? How many answers are you going to have? 2 of what type?
Positive.
What type, so? I mean, real, imaginary? 2 real. Remember, the discriminant tells you how much, the number of solutions and the type. So it's a positive value, but you can have 2 reals. So that means I have 136 plus or minus, well, the square root of that junk. Bless you. Yeah, negative 1. So this is the square root, okay? So I have 136. Let's move this over here. Didn't work. I have negative 136 plus or minus 960.48, blah, 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 all over 36. And I'm looking to solve for the number, what year something's going to occur. Do I want this value to be a positive value or a negative value? Positive. So which one am I going to do? Negative 136 plus or negative 136 minus?
Minus.
I'm going to do plus because what's my denominator? Positive. I want a positive divided by a positive. There's a couple other problems on here. You have a negative and you want divided by a negative. That's what you want to do. So you have to be careful of what the question's asking. It's looking for time. It's looking for years. You want positive value. When you do that, you get approximately 22.9 years. When you add that to 1979, it gets you to about 2002. It's like 2001.9 years. So I would say 2003. Okay. Does that make sense? Remember, quadratic formula is going to solve just about all these for you without too much of a hassle. Without having to worry about your windows and all that kind of junk. What else on the word problem? We got the rest of those all right? Three. If an object is dropped from a height of 75 feet, the function is that. How long does it take to reach the ground? In other words, when does d equal 0? So here's what happens. All you have to do here is solve for t. Subtract 75, divided by negative 16, and then take the square root. And that gives you your time. It's roughly 2.17 seconds. That was 3. Okay. If you're setting your time, if you're setting the distance equal to 0 when it drops and hits the ground, how long did it take to get there? Hey! Give me all the stuff on there. Yes, sir. No, you don't have to. I mean, if you graph it, I mean, you get the idea. It's a parabola. Bless you. It's a parabola that starts up here and it's just going like this. You don't really need a graph on that problem. I know someone said graph, but you get the idea of the sketch here. Yep. Yep. Because you're taking square roots and you have plus minus. There we go. All right, let's start looking at the first page. Let's start with completing the square. What do you got?
You can do the first page and then go to.
I'll get to there. On 2. X squared plus 17x plus 2 equals 9x plus 11. Solve by completing the square, which means I got to get it the a value equal to positive 1. Subtract the 9, subtract the 11. I wind up with 8x. You know, I'm going to move the 2 over. Blank equals 9. You can do that right away, because I'm going to have to move C anyway. Okay? From here, take half of B. Well, half of B is 4. That goes in my term. Square it, and I add 16 to both sides. 9 and 16 gives me 25. Now, in order to solve it, take the square root. You get x plus 4 equals plus or minus 5. Subtract the 4, we get x equals negative 4 plus or minus 5. So you're, in this case, if you left it like that, it's the end of the world. This is number 2. It's completing the square. It's not the end of the world, but if you add it, you get 1. If you subtract it, you get negative 9. Those are your 2 solutions.
What was it? 1 and negative 9?
Yep. Half of B and square it, add to both sides.
Negative 4.
Yeah, let me do 4. Shane? You all right? Move everything to one side. I wind up 2x squared minus 8x plus 35 is 0. Now, the first rule for dealing with completing the square is that your a value has to be equal to a positive 1, which means I have to divide everything here by 2. So I'm going to divide everything by 2, and then I'm also going to move the 35 to the other side at the same time. So I get x squared minus 4x blank equals negative 35 over 2. Complete the square. Half of b and square it. Half of negative 4 is negative 2. That goes into my term. Square it, and I'm adding 4 to both sides. What I did there, instead of just adding 4, I added 8 over 2. Which is the same thing as 4. So negative 35 and 8 gives me negative 27 over 2. Now I have to undo the squaring. Undo squaring, you do what? We square root it. Whenever I take a square root over an equal sign, it becomes plus minus. So I have x minus 2 is plus or minus square root of negative 27 over the square root of 2. More than one way to set this problem up from here. Obviously, I have a negative square root, so what has to come out of there? I, very good. Could I rationalize it right now, or could I try to simplify it to 27? I can do either one. Okay. The square root of 27, well, what's the perfect square hiding in there? 9. So the square root of 27 would be 3 root 3. So the numerator becomes plus or minus 3i root 3 all over root 2. I have not moved this negative 2 yet. I'll do that at the very end. So now, how do I undo the root 2 on the denominator? Okay. Multiply top and bottom by root 2. So you wind up with x minus 2 is plus or minus 3I root 6 over 2. Lastly, move the 2 over. And there's your answer. I know the solution on this thing had this as 4 plus or minus 3I root 6 all over 2. They're the same thing because what's 4 divided by 2? It's 2. That's all. Yeah, sure.
So when you multiply times the square root of 2, you would just do 3 to 2?
Yeah. Properties are radicals, that's all you have to do. Goes right through it. Okay? If you set it up the other way where you try to rationalize right off the bat, you'd wind up with negative 54 over 2. The square root of 54 you would have found also would have been 9 times 6, so you would have 3 root 6. It doesn't matter. Either way, it's perfectly fine. All right? What else on that front page?
Number 10.
What do you got?
Can you just do like one from the factoring and one from the square root?
Which one?
Doesn't really matter. I just want to
10
see
from the
it.
square root, 5. You like.
I've had the most questions on this one. This 6, I believe. What I'd like to do here is, since I'm factoring, I want to solve by factoring, I want to get my A value to be positive. So I'm going to move everything from the right to the left. I wind up with 35x squared plus 24x minus 35 is 0. Now I have to go through my rules of factoring. I would start by looking for a GCF, and I could look real hard, but I'm not going to find it. So that means I have to multiply 35 and negative 35 to get my multiples of that, to see what adds up to 24. Remember, 35 and 35 is negative 1225 that I want to add to 24. And I don't know about you, but I'm not going to sit there all day and list all those out. So do you remember the trick on your calculator? Go to your y equals, go on. I want 12, 25 divided by x. And as you go through your table, it'll start listing x squared if I want to try to find the radical. Here I'm just looking for factors.
1225 divided by x.
Yeah. That'll give me my factors. If I do 1225 divided by x squared, it'll help me find my perfect squares. Okay. Here I just start scrolling through, and I'm looking to see where I can find integer values and see if any of them mix together to get a 24. And lo and behold, I got one at 25 and 49. Positive 49, negative
Does it
25.
put
What's-
the like answer in the y column? So if I'm looking to get 24, 24 is going to be in the y column? On the calculator?
No. What you're trying to do is trying to do a combination. Can I do 25 and 49? Can I make that equal to 24 somehow?
Unless you just add them.
Add or subtract it, yeah, that's what you're looking for. What this divide by x allows you to be able to do is it's looking for the integer values of your factors. It's just scrolling.
A bunch of factors.
That's what it's doing. It's giving you factors. So I know it's 25 and 49, and if I wanted it to be positive 24, which one should I put? Which one's positive then?
49.
Yeah. So I get 35x squared minus 25x plus 49. And most people, once they realize that they can use your calculator to get those factor terms, the rest of it isn't so bad because now it's just by grouping. When you're factoring by grouping, that means all you have to worry about doing is getting your GCFs. Here I have 5x. So I have 7x minus 5. Here I have a GCF of 7. So I have 7x minus 5. Convenient how those are the same thing. It means we did it right. And then lastly, to get your zeros, you set them both equal to 0. In this case, you get 5 over 7 and negative 7 over 5. If we were dealing with slopes, they'd be perpendicular. Opposite reciprocals. Come on.
I get that.
Thanks.
That's how you get it.
So that was the feature.
He really likes you. Yes,
I second that.
Same idea. 5 is you're going to kick yourself when you see this. Don't even bother with that. Move to 2. Is that a perfect square? Is this a perfect square? Do you see how the signs go negative plus? That means both terms are both negative, aren't they? I'm sorry, it's just negative 3, which is 0. Am I right? Once you realize it, oh, that's nuts. Or you can go through the whole spiel of everything, factor everything out, and you get the same result. If you're not sure of your terms, if you have to multiply out, or if you got to get GCFs, you can use the calculator to go through the table function. Yes, sir?
Well, the ones where I just said like
Simplify, yeah.
Like you wanted to get into the 4x minus 12 form.
Yeah.
That one would I write both of them, or would I just put
You
square?
can do either one. If you wrote it 4x minus 1220 squared,
Like for one of them you meant that, but I hit squared and I did.
oh, that's okay. I wouldn't have yelled at you. Yeah.
From the answer key, it says 5 is 3 halves.
Yeah, because
Yeah.
Yeah, it
it would be 4x minus 96 and then 4x minus 24, I think. Or no.
I thought that was
I
a
don't
perfect
know.
square.
I got 6.
4.
It's the answer key said 6 3/2.
And the answer key,
What?
12, 1 What? 48. 96. Oh yeah, this isn't the perfect square. It isn't the square triangle here.
yeah, 'cause
I jumped ahead. I didn't check to see if this was the middle term. Yeah, you're right.
You can pull out an 8.
Is that what you can?
Yeah.
Yeah, I went too fast and just assumed that it worked. I didn't double check that middle term there. It wouldn't have worked. If you take the 8 out, then what do you get? You have 2x squared minus 15x, and then, oh, that's much more manageable. When you pull out the 8, since you're equaling it to 0, do you have to worry about that 8 anymore? No. I don't. I don't have to worry about it at all. So now what's 2 times 18? 36. To get 36 to add to 15, to negative 15, that's your negative 9, negative 6. It's a bad day here. You're right. 9 and 6 is 54. Hi, how are you? Hey. Pick on Murphy Day. I get one thing wrong, next thing you know, everything else is all bad. So here's your 2. Negative 3. Yeah, this is where you get that. So, yeah. So it's 2x minus 3, x minus 6. So it's 3 halves and 6. There you go. Sorry about that. I didn't even double check that middle one. In order for it to work like I was showing, that middle term would have been the 4 times 12 double. It would have been 48, so I I went too fast. I never tell you guys that you're going too fast in math problems, right?
Wait, so
Silly mistake. Silly mistake chart, that's right. You should take out a buck. I don't even know if I have $1. But yes, sir.
Like for that one, the outside one is 2x minus 3, right?
Yeah.
What did you do? What about the 8? Did you do anything with that?
No, what happens when you have one side equal to 0? If I divide out by 8, what's 0 divided by 8?
0.
It just continues
in
on.
the packet, I times the 2x by 2x minus the
Oh, you're multiplying in the back end. Yeah, don't do that. You factor it out. If it's equal to 0 on the other side, it just kind of goes away.
I don't even know what ones I did that.
When you have the square root ones, yeah. Go ahead.
It's unrelevant currently.
Unrelevant or irrelevant? It's impossible.
Wait, is this number 10? No.
Oh, you wanted 10. Sorry. I couldn't remember which one you were looking at. Okay. Move the 11. Divide by 15.
Yeah.
Take the square root.
All right.
Now,
Okay.
at this point here, what I'm going to try and do is simplify out. 464, do you guys remember how to check to see if there's a perfect square in that? No. All right. Well, what am I going to do inside that 464 right away, though? What can I take out of that? I can take the I out. So I'm going to have plus or minus I root 464. Did it simplify out? 4 root 29. Now, remember, this is still over the square root of 15. In your calculators, do you remember how to check to see if you can get a perfect square? Remember, go to your table. We want 464 divided by x squared. Then go through your table. You're looking to see for the largest, or excuse me, the smallest non-decimal answer you get in the y column. 4 root 29.
Are you serious? That's
What? Oh, yeah.
Remember, go to your table, go whatever number divided by x squared, and that'll give you whatever the smallest value is before that's not a decimal in the y column. That's underneath the radical, so it's 4 root 29. So right now you have plus or minus 4I root 29 over the square root of 15. In order now to get rid of that root 15, you have to multiply the top and bottom by root 15. So 29 times 15 is how much? And there's your answer. Plus or minus 4I root 35. 4I root 435 over 15.
Don't worry, Mr. Okay, we all do it.
Yes, sir.
Next words, if I don't, if I just the negative square root
This is
and then times that by
It'll work. It works just fine. It doesn't matter when you simplify. If you simplify up front or you simplify later, you're going to get the same stuff. That's fine. There's nothing wrong with that. Nothing wrong with that at all. Yes, ma'am. All right. Second page, Ellis.
This is a little irrelevant, but and corresponding to math. What was his feedback on our video?
Kick butt. I want to say something else, but it was pretty awesome.
It was video.
A lot of people loved it. So yeah. I had requests that you guys walk around the halls when it gets close to Christmas and sing that as a Christmas carol.
Oh, we could so do that.
Yeah,
And
definitely.
dress up as like the four elves or
So we're a
something
horseman?
of the apocalypse. I don't think that goes well with Christmas time.
That's all right.
Just throwing it
Yeah,
out there,
sure.
you take it, you
How'd
can
you
leave
get
it.
the 29
To get rid of the radical in the denominator, remember you multiply top and bottom?
Oh, yeah, never mind.
That's where I was getting at. I said it, I didn't write it down.
Oh, yeah, I was looking
I
at
never cracking up.
Miracles, you know. That's what
I
happens.
have a question on that.
Second page. Oh, what's up?
Just one question on that. Could you write it as the square root of 32 and 3/10?
No, no decimals. Oh, square. I'm sorry. So what's it's 323 equals 10x squared.
Yeah.
So it's 323 over 10 plus or minus. So this is plus or minus the square root of 3230 over 10.
Could you write it as 32, the square root of 32 and 3/10?
No.
The rock.
Second page. I don't know if you can simplify 32 to 30. You might. I don't know. What number? Second page. What do we got?
$17.
17. Is that a perfect square? Is that a perfect square?
Yeah.
Is that a subtraction symbol?
Yeah.
20 is written backwards from what you're accustomed to seeing. What's the first rule of factoring?
You take out the GCF.
Okay.
Why don't you just
What's that? First rule of factoring is to find a GCF. In this case here, I can divide everything by 7. If I divide everything out by 7, we get 81 minus, I forget, what is it, 15? No, 18. Okay. Now, in your head, you're sitting here thinking, okay, kind of makes sense. Is 81 a perfect square?
Yep.
Is p squared a perfect square? What's the square root of 81? So if I double it, would I get my middle term somehow? Okay. What I want you to also notice is that you see how your signs go negative, positive. So it's asking you what are two numbers you multiply together that are positive, but you add them together to get negative. That means they both have to be negatives. So you get 7, 9 minus p quantity squared. Now in this case, I have to keep that 7 out front because this is not a set equal to 0 problem. When I'm factoring it out, I have to leave it there. So you can either write it as 9 minus p quantity squared, or you could write it as 9 minus p, 9 minus p. Either one is perfectly fine. All right, either one of those solutions would have been
So
correct.
if it equals 0, you don't need 7 at all. But if it doesn't equal 0,
Correct. Or better yet, if there's an equal sign, you can get rid of it. If there isn't, keep it. Okay? Because sometimes it equals 4. You know what I mean? But you move stuff around and. And you can write it out as quantity squared, or you can just duplicate it if you'd like. Either one is a perfectly fine solution with me. I have no problems with either one. Any others on that second page? Yes, sir. Sure. I heard 14. I'll get to that one too. 11. We have 8x squared minus 8 is negative 209. Add 8. Divide by 8. (201). I know I can divide it by 3. Does it give me a perfect square in there? Can I divide it by 9? Well, what I'm doing here is that I know that the square root of 8 is going to be 2 root 2. I know that I have a negative 201, so I know I'm going to have a plus or minus I in here somewhere. But what I want to do is try to figure out if I can have a perfect square in 201. So I'm going to check it. Go to my table with 201. And it just stays at 201 then, right? Yep, it stays at 201. It does not simplify out, so you wind up with, but I have to get rid of that root 2 in the denominator. What do I multiply top and bottom by? By root 2. I don't have to multiply by 2 root 2, I just multiply by the radical.
why can't you just do 10 to the square root of 8?
You can do that too, but then you have to simplify later. What's root 2 times root 2? 2. What's 2 times 2? So your answer is plus or minus I root 402 over 4. Okay? And once again, the only reason, could I have multiplied top and bottom by the square root of 8? Yes. But you have to remember, when you're multiplying by an 8, there's a perfect square hiding in it. That's why I simplified the square root of 8 first. It's just a little bit easier. Okay? It's just a little bit easier to see. Graphing, remember when you're graphing, find a vertex, find zeros, solid or dotted. When you're shading, you just pick any point not on the curve, inside or outside. There were no overlapping ones on these, but remember we'll have overlapping tomorrow. But it's the same idea. You're looking for the overlap shape. I'm not trying to belittle the idea of the graphing, but I know that you guys did really well on that. I don't think there was much of a hassle on it. As far as the rest of the stuff is concerned in this chapter, it goes back into your I again when you're dealing with simplifying imaginary numbers. I'm going to show you a quick one of those. Like I said, I didn't have a chance, I didn't get them onto this sheet, but let's say you had to do 2 minus 3i and you're dividing it by 4 plus 5i. How do you simplify that?
No idea.
No idea.
No clue.
Wait, what did you?
What I want to do is I want to simplify that. I don't want that imaginary number in that denominator. What do I have to multiply top and bottom by? You've already said it.
4 minus 5. 4
Remember, I multiplied by the conjugate.
Oh,
4 minus 5i squared, or 5i.
Second?
Help yourself, just sign them out.
Foil.
Foil. All right. In your denominator, you're not going to have a middle term. Your I value will drop out. So you wind up with 16 minus 25i squared. And anytime you have I squared, what do you rewrite that as? Very good, -1. So this is 16 minus 25 times -1.
Wait, what number is this?
I just made this up. Yeah. So in this case here, I wind up with 16 plus 25, otherwise known as 41. So my denominator is going to be 41. My numerator, then, I have to FOIL everything out and simplify again. So when I FOIL out my numerator, I get 8 minus 10i minus 12i plus 15i squared. That plus 15i squared turns into what? Minus 15, very good. So I have 8 minus 15, so that's -7 minus 22i. And I'm done. The only other possible thing you might have to do when you have a situation like this is, let's say all 3 numbers were even, or all 3 numbers were multiples of 3, something along those lines. Then you could simplify it out a little bit further. Okay? Did that make sense?
So you just leave it at -7 minus 22i over 41?
Exactly. Your imaginaries in the numerator, perfectly fine. Imaginaries in the bottom and the denominator, bad. All right? Yes, sir.
What if it was on the bottom? 5i plus 4.
5i plus 4. Then you multiply it by 5i minus 4.
I know it's the same.
But you're not going to see it written like that because that's not proper. I's always come second. All right, the I's already written second. The other parts on the test here, you still have to remember that we did section 5.8. Remember in section 5.8, I was giving you guys vertex, I was giving you guys a point, write it in vertex form, giving you guys a point, a pair of intercepts, write it in intercept form, giving you guys 3 points, write it into standard form. We did those. I scared you for a minute when you had to do the matrices, and you guys were like, oh, this is really easy. So let's just revisit real fast just so you remember that. For example, if I want to do a vertex form,
Are we gonna remember those?
yeah, I don't know. If I'm going to do a vertex form, given a point and a vertex, remember vertex form is y equals a x minus h quantity squared plus k. There are 5 variables there. I know 4 of them. Fill in the blanks, and which one am I going to solve for? Good. Vertex is your h and k. Points are your x and y. Remember, when you see this, guys, whether it's this form or intercept form, make sure you label them. It's very simple to accidentally flip-flop them around. That's where you're going to make mistakes. So 54 is a -3 minus 1 quantity squared minus 10. That's -4 squared. So that's 16 minus 10 is, oh, sorry, excuse me. 16a equals 64. Divide out, we get what, 4? So your value of a is 4. Rewrite in with your h and k. Y equals 4x minus 1 quantity squared minus 10. And that's your final solution. If you were getting sets of ordered pairs and you had to write the equation in standard form, that's when you had to use your matrix. Remember the nice easy trick with that? We had 3 ordered pairs. Remember that? If you had your 3 ordered pairs and you had to write it out in standard form, remember that's your ax squared plus bx plus c. When you do the matrix in these, this is your x squared column, x, and then what's the third column?
1.
Ones, and what's this?
Y.
Y. Good. So what's 1 squared?
1.
What's 3 squared? What's and then yeah, inverse. And that'll give you my values for A, B, and C respectively. Okay? And then just rewrite out. You guys all freaked out when you first saw that, thought you had to do a system with 3 by 3s. You're like, I don't want to do that. Yes, sir.
And it, so yeah, so it's all the x's squared and the one.
X squared,
And
X,
that's just x.
1s, Y. Other than that, my suggestion to you guys as far as other things to look at, just go through the chapter review in the book, go through the chapter test in the book. It's all right there. There's nothing on this that's going to freak you out. It's very straightforward. I think there's 14 questions total. You'll have plenty of time to do everything. Yes, sir? I don't remember off the top of my head.
Is that, wait, it's a test, right? Not a quiz?
Yeah, it's a test.
Is
So-
it like 10 points?
What, the test? Yeah, it's about 10 points. Maybe more. Maybe more. Like a smidge more. Well, it's 55% of your grade, but just count.
Do I need to?
Jackass.
All right. Are there any other questions about something I can throw on here real quick? We've got a few minutes. I can continue to help you out here. Yeah. Sure. Number 16 on the second page. Number 16. In this one, it's asking you to use the quadratic formula. It's asking you to use the quadratic formula to solve. So that means you got to set one side equal to 0. So you have negative 7x squared minus 7x minus 10 is 0. When you go to use the quadratic, remember, opposite of b plus or minus the square root, b squared minus 4ac all over 2a. One of the things that people tend to mess up are forgetting signs, especially when you have a ton of negatives. So take a quick second and label what a is, what b is, and what c is. And then fill in the blanks. Opposite of negative 7 is 7. When you square your value of b, if you type in your calculator negative 7 squared, you're going to get negative 49, and you're going to get it wrong. Remember, if you're going to use your calculator to square something, you've got to have it in parentheses, or just remember that a negative value squared is always positive.
Or just take the negative side.
Why does it do that? Why does it go?
It thinks, when you put in the negative sign, it thinks opposite of 7 squared,
Oh,
instead of opposite of 7 squared.
okay.
Okay, so we wind up with 28 times negative 10 is negative 280. So I have 49 minus 280, which is negative 231, thank you. So I have 7 plus or minus the square root of negative 231 over negative 14. All I need to do there is check, I know I gotta take the I value out, but I also want to check in my calculator if there's a perfect square hiding in it. Was there? So my final answer then would be 7 plus or minus I root 231 over negative 14. Is there one?
No, it says negative 7.
You know what they do? It says negative 7 over positive 14. Simple.
So that's the answer?
Yeah. What her question was is that the answers in the backs had the negative 7 and then it had a positive 14. It means the same thing. Remember, when you have a fraction, -1/2 is the same thing as 1 over -2, which is the same thing as negative in front of the fraction marks. It means the same thing. So if you left it up front or on the bottom, it doesn't matter. I'm usually going to, when we have, especially when we're doing quadratic formula, I'll probably just leave the negative at the bottom because that works out to be that way. Okay? Yes, sir?
Those three that you did are
For which ones?
like the three you did on the board.
Yeah.
Okay.
Yeah, those are on the packet, yeah. Remember, I'm trying to think what else is there. Don't forget your calculators. They're very helpful. Yes, yeah. Aaron. Ryan, you had a question?
Yeah, you did,
Oh, intercept form. Yeah, if you had an intercept form, you're doing the same idea, but you're using a different formula.
Is there like X minus?
Yeah. Your intercept form is y equals a, x minus p, x minus q. Your intercepts, so this case it would have been 8 equals a, -4 plus 2, -4 minus 2. I'm just substituting in. Your intercept values are that p and q value, and then you still solve for a. Does that make sense?
P and Q.
That's the intercepts, p, q. That's all that is. So you wind up with -2 times -6, you get 12. So 8 is 12a. So you get 2/3 is your a value. So your final answer would have been y equals 2/3 x plus 2, x minus 2. I expect you guys to do really well on this, to tell you the truth.
Is this one of the hardest chapters for kids?